is another item that has made big news in terms of the sea ice in Antarctica reaching a low this year in 2023. It's worth looking at it in a broader context, and there are a couple of contexts for it. So I just wanted to touch on it here. So the headlines have been again blasting, saying Antarctic sea ice is at a very concerning record low. It's winter in Antarctica when sea ice cover typically grows, but this year's sea ice is way behind, reaching record lows with implications for the planet. Is that accurate? Well, there are weather responses that happen immediately with sea ice losses, so it's good. But what does it mean in terms of the trends? So here is another one that has a point to the implications of this, which is good. So this paper talks about record low 2022 Antarctic sea ice led to catastrophic breeding failure of emperor penguins. Early sea ice breakage ends up affecting the nursing of the penguin babies, which have to survive the winter to make it to adulthood, which is called recruitment in the biology business. But what is the context? Why is 2023 so different? Well, global warming has been happening, and there are patterns, and we know there is Arctic amplification. Arctic is warming faster than pretty much every place on Earth. Antarctica doesn't have such a strong polar amplification for various reasons, and El Nino is happening. El Nino, which you can look up in the other podcasts, I have many of them, is a process where heat that has been accumulating in the ocean gets released during an El Nino, so it creates a mini global warming, and now it will add to the background global warming that's going on. And El Nino has teleconnections, so remote impacts to the Arctic and the Antarctic as well, which are well known. So if you look at this animation, it shows you that the El Nino took hold early this year with this warming in the eastern equatorial Pacific, tropical Pacific, extending westward. There are many details where you can look at my podcast, but it's also unusual in the sense that it is warming pretty much across the basin, and there are details which should tell you, which you can look up in my podcast, that typically El Nino means there is a cooling on this side and warming on this side, but now global warming is imposing, or El Nino is superposing on global warming and creating these unusual patterns of warming across the basin. And these are other figures of how the warming looks. So this Northwest Canada, America, and western parts have been quite warm, and this year is getting a lot of attention because of many new records being broken each month, and so on and so forth, right? Keeping that in mind, let's come back to Antarctic and Arctic just to have a sense of why Antarctic sea ice loss is unusual. So this is a nice image from a NASA website which explains the differences between Arctic and Antarctic sea ice. And obviously Arctic is a semi-enclosed basin with a lot of freshwater input from the continents, hence the sea ice can grow pretty thick in this region, whereas in the open ocean typically it doesn't get very thick because of the circulation that get induced by sea ice formation. Very briefly, sea ice forms, it rejects the salts or the brine, which gets heavier, so water becomes heavier, it sinks, new water comes in, so new heat comes in, and the sea ice doesn't grow very thick. So you'll find thicker sea ice in the Arctic than in Antarctic because it's all in the open ocean. And the ocean is warming, atmosphere warms, snowfall happens, the glaciers that flow down onto the ocean, the shelf ice get melted from below by the warm ocean, but snowfall can increase glacier mass. And so all these kind of complicated dynamics in the Antarctic are very different than what happens over the Arctic overall. So if you look at the seasonality of Arctic sea ice versus Antarctic sea ice, you can see this is March and this this is September. So now boreal summer, obviously you get minimum sea ice extent, and this matters because this is what grows back into the winter months. So if this extent is smaller, then you have less sea ice growing potentially, and similar things happen. So the austral summer minimum versus austral winter maximum here. So the seasons are flipped, of course. So we have to keep these things in mind. And the Arctic, it's well known because the sea ice loss is fairly serious, and it's been going on for a few decades now. But it's unusual for the Antarctic because until very recently, we've been talking about Arctic and Antarctic sea ice contrasts. This is from November 1978 to October 2020. You can see that the Antarctic sea ice trend has been positive with large swings more recently, and the Arctic sea ice has shown a continuous decline in terms of sea ice extent. So sea ice can be measured but just by the area covered by sea ice versus also thickness, volume of sea ice, and so on and so forth, which we will not worry about, because you can have Swiss cheese kind of sea ice distribution where it's not continuous but it has holes, and still you get the extent that is covered by sea ice overall, and so on. So keeping this in mind, suddenly we are worried this year. So if you look at Antarctic sea ice extent for the decades, 70s, 79 to 89, 90 to 99, 2000 to 2009, 2010 to 2019, 2020, 2021, you had record low appearing in the summer fall of 2017 in terms of extension in millions of square kilometers for Antarctica. So this is area of the ocean with at least 15% sea ice, so that you can account for discontinuities in the sea ice cover. And in fact, record high occurred on September 21, 2014. So that's been the seasonal cycle with lows and highs, and the trend has generally been seen as growing. But suddenly, so this is another figure showing minimum and maximum Antarctic sea ice extents for 1979 to 2020. So this is minimum 5-day. So there are trend lines here and the maximum. So you can see that the trends are not so obvious in Antarctic minimum and maximum sea ice. So you contrast that with what's happening in 2023, and I got motivated by this nice infographic put out by the Visual Capitalist, taking data from the US Ice Center at the National Sea Ice Data Center in Colorado. This is Antarctica's shrinking sea ice in 2022 and 2023. Sea ice extent in Antarctica continued to reach record lows. Here is the graphic. I cut it off randomly, so ignore this part. So this is the record low showing here in millions of square kilometers. Again, the average for 1979 to 2022 is shown here with the 14 minimum and the 17 maximum in there. Global average temperatures are breaking records in the months between June and September this year, very largely attributable to the El Nino superposition on global warming and the wind changes that have also manifested as warming of the ocean over much of the globe, especially over the Atlantic from the southern hemisphere into the northern hemisphere. The Antarctic Peninsula usually averages 14 degrees Fahrenheit, but in 2023 it reached over 18 degrees Fahrenheit, which is a massive 4-degree warming. So you can see here that 2022 previous record low on average for the month of June to September, and 2023 ended up being much lower, significantly lower for sure. The 2023 World Meteorological Organization reports that sea ice is 17% below the average for this time of the year. So now the key question is this related to El Nino, and will it come back next year, or are we tipping over into some no return state? That's not very easy to say right now, because if the system rebounds back into a very strong La Nina next year, and La Ninas tend to persist for multiple years as they did from 2020 to 2022, then you know that the sea ice could look very different next year. So we have to keep that in mind. Changing sea ice concentrations. So this is another thing which is important in addition to the extent. So here is the median extent for 1981 to 2021, and you are looking at this year's data here for August 22, 2023. So there are some regions where the extent is higher, there are some regions where it's lower. So you do have to watch out when you look at averages like this versus a map like this. So there are regional specificities to where the sea ice is shrinking, and there will be feedback, ice albedo feedbacks, for example. So we have to see how this will pan out in the next year. So in August 2023, sea ice concentrations have dwindled enough to show more than 1 million square miles of sea ice loss compared with averages over 30 years. So overall, there are some gains, but the loss is much higher at 1 million square miles of sea ice. Okay, so just to conclude, global impacts from shrinking sea ice. Less reflected sunlight is instead of absorbed by the ocean, causing warming. This is the ice albedo feedback, which can be very significant and is also responsible for the Arctic amplification or the polar amplification around the North Pole. Changing currents, lack of ice reshapes water currents and global nutrient shuffling, and we of course just looked at the penguin problem. And rise in sea levels. Melting Antarctic ice can contribute to more than a meter of sea level rise by 2100. But here you have to be careful. This is not sea ice. Sea ice doesn't contribute to sea level rise because it's already in the water. It's like ice cubes melting in a glass. It's not going to increase your volume. But it's the shelf ice that flows onto the oceans, and that is called that can break off and melt, which can add to sea level rise and so on. So I thought it's important to make these couple of points so that we do have a context for this year's tremendous anomalies, and then have a caveat that this is just for this year, this winter. So let's wait and see if this is really something of a indicator for permanent changes, or if the system is going to recover and the Arctic the Antarctic goes back to being dramatically different from the Arctic in terms of sea ice loss and the trends overall for seasonal minima and maxima. Okay, now I will leave it here.